Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over 5 worked examples to show you how to do problems involving displacement, velocity and acceleration. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says the displacement of a moving object is given by s equals 6t squared plus 8. Part A says using calculus methods determine an expression for the velocity of the object. Well, starting with our displacement expression, that's s equals 6t squared plus 8. To find the velocity, we can use v equals ds by dt, i.e. velocity equals the rate of change of displacement, which remember just means differentiating the displacement s with respect to time t. So remember to do that, we bring the power down and multiply it, so we get 12t plus 0 here, because differentiating 8 will give us 0. So we therefore have that v equals 12t. Part B says sketch a velocity time graph for the object. Numerical values are required on both axes. Well, to see what this is going to look like on a velocity time graph, we need to draw a table with time in seconds and velocity in meters per second, and then we can calculate what the velocity is at different times. So starting at 0 seconds, we have v equals 12 times 0, which is 0, and then going up in 1 second intervals, at 1 second we have v equals 12 times 1, which is 12, at t equals 2, we have v equals 12 times 2, which is 24, and so on up to 5 seconds. So we can sketch our axes and then our labels in units, so we've got v in meters per second and time in seconds, and then we can put some numbers on the scale. So we have the origin 0, we have 60 meters per second up here, and we have 5 seconds here. Now if you want, you could insert all of these numbers on the axes, but I'm just drawing where the initial point is at 0, 0, and then where the final point is at 560. So we're going to have a point here, and a point up here, and then all the other points are going to be in between. So we're going to have a line of best fit which looks something like this. And note how we've got a positively sloping diagonal line on a velocity time graph, which represents a uniform acceleration. Question 2 says the expression for the displacement of a moving object after time t is s equals t squared minus 10t plus 8. Using calculus methods, part A says determine an expression for the velocity of the object. Well, starting with the displacement expression, we have s equals t squared minus 10t plus 8. And remember, to find velocity from displacement, we have that v equals ds by dt, i.e. velocity equals the rate of change of displacement, and therefore differentiating this with respect to time, remember we bring the power down and multiply it by the number in front, so that becomes 2t minus 10. Part B says using calculus methods determine the acceleration of the object. Well, remember to find acceleration from velocity, we have the a equals dv by dt from the relationship sheet, which just tells us that acceleration equals the rate of change of velocity. So that means we can differentiate this expression with respect to time, so that will just become 2 meters per second squared. And the reason we put the unit in there is because we were talking about an acceleration here, and we got a constant value. So we could say that this is a constant acceleration of 2 meters per second squared. Question 3 says the motion of an object is given by s equals 8t squared minus 4t plus 6. Part A says using calculus methods determine an expression for the velocity of the object. Well, again, starting with the displacement s, we have s equals 8t squared minus 4t plus 6, and to find velocity we can use v equals ds by dt, i.e. velocity is a rate of change of displacement, so we want to differentiate this with respect to time, so we bring the power down and multiply it, so that becomes 16t minus 4. Part B says to determine the time at which the object will be stationary. Well, we can say that the object will be stationary when v equals 0, so all we need to do now is take this expression for v and sub in for v equals 0 and try and find the time t. So we have that 0 equals 16t minus 4, so adding 4 to both sides we get 16t equals 4, and then dividing both sides by 16 will give us t on its own, so that gives us t equals 0.25 seconds. Lastly, part C says to determine the acceleration of the object. Well, remember, acceleration is related to velocity through this equation here, a equals dv by dt. In other words, acceleration equals rate of change of velocity. So all we need to do is take this expression up here and differentiate it, so that will just become 16. But we can put our units in here as well to get 16 meters per second squared, i.e. this is a constant acceleration of 16 meters per second squared. Question 4 says the acceleration of a particle is described by the expression a equals 2.5t, where t is in seconds and a is in meters per second squared. The initial velocity of the particle is 6.0 meters per second. Determine the velocity of the particle after 2.0 seconds. Well, we're given an expression for acceleration, and we want to find an expression for velocity first of all. So to do that, we want to integrate the acceleration with respect to time. So we can rewrite this a equals 2.5t as a equals dv by dt equals 2.5t, where this is just the equation from the relationship sheet. And then we can ignore this a equals part and just deal with the dv by dt equals 2.5t. So if we take that and integrate both sides with respect to time, we have the integral of dv by dt is equal to the integral of 2.5t dt. Now integrating this acceleration with respect to time will just give us v on the left hand side, and then integrating this, remember we raise the power by 1 and divide by the new power, so that will give us 2.5t squared divided by 2 plus c, where c is a constant. and this simplifies to v equals 1.25t squared plus c. Next we need to consider the initial conditions, and this just means what happens when time t equals 0. Well, we can say that at time t equals 0, remember we were told the initial velocity of the particle is 6.0 meters per second. So that means we can say v equals 6.0, so therefore if t equals 0, then c will equal v, and therefore c must equal the 6.0. So therefore we can rewrite this statement as v equals 1.25t squared plus 6.0. And remember we want to find the velocity after 2.0 seconds, so we could say lastly substitute the time value, so we have v equals 1.25 times 2.0 squared plus 6.0, and putting that into your calculator should give you an answer of 11 meters per second. Lastly, question 5 says energy is stored in a clockwork toy car by winding up an internal spring using a key. The car is released on a horizontal surface and moves forward in a straight line. It eventually comes to rest. The velocity v of the car at time t after its release is given by the relationship v equals 0.0071t minus 0.00025t squared, where v is measured in meters per second and t is measured in seconds. Using calculus methods, part A says determine the acceleration of the car 20.0 seconds after its release. Well, we're given a velocity expression here and we want an expression for acceleration first. So remember, to get acceleration from velocity, we can differentiate v with respect to time. So we have a equals dv by dt, i.e. acceleration is the rate of change of velocity from the relationship sheet, and that's the same as writing d by dt, the differential of 0.0071t minus 0.00025t squared. So differentiating this, it would just become 0.0071 minus, and remember we bring the power down and multiply it and take 1 off the power, so this will become 0.0005t. And now that we have a general expression for acceleration, we can substitute in the time value of 20.0 seconds. So we have a equals 0.0071 minus 0.0005 times 20.0, and putting that into your calculator should give you an answer of minus 0.0029 meters per second squared. And don't worry about the negative, remember this just tells us the object is slowing down, which is fine because we're told in the question it eventually comes to rest. Lastly, part B says determine the distance travelled by the car 20.0 seconds after its release. Well, looking back at the question, remember we're given an expression for velocity, and now we're asked to calculate distance. So to find displacement or distance from velocity, remember we need to integrate rather than differentiate. So we can say integrate v with respect to time, so we can write v in the form of ds by dt from the relationship sheet, which is equal to 0.0071t minus 0.00025t squared. And then we can ignore the v equals bit and just deal with the ds by dt equals this, and integrate both sides with respect to time. So we have the integral of ds by dt equals the integral of 0.0071t minus 0.00025t squared dt, and integrating velocity with respect to time will just give us displacement s, and to find the integral of this, remember we want to raise the power by 1 and divide by the new power. So we have 0.0071t squared divided by 2 minus, and again doing the same to this one, raising the power by 1 and dividing by the new power, we have minus 0.00025t cubed over 3 plus c, where c is a constant. And then to find what the constant c is, we need to consider the initial conditions, which remember is just what happens when time t equals 0. So we can say that at time t equals 0, the displacement of the car is 0 because it's not moved anywhere yet. So therefore if t equals 0, then these are both 0, so therefore c must equal s. And if s is 0 at this time, then c must also equal 0. So that means this simplifies to s equals 0.0071t squared over 2 minus 0.00025t cubed over 3. And lastly, we can substitute the time value of 20.0 seconds. So we have s equals 0.0071 times 20.0 squared divided by 2 minus 0.00025 times 20.0 cubed divided by 3. And putting that into your calculator should give you an answer of 0.75 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.